Imagine waking up one morning to look at the sky and finding that the moon has simply vanished. The familiar silver disk that once hung like a silent companion above the horizon is gone, leaving only empty darkness where its gentle glow used to be. For a moment, the night feels unnerving, as if something fundamental in the world has quietly slipped away. With the moon's disappearance, Earth's celestial choreography snaps out of harmony, ushering in profound changes that ripple through our planet's oceans, atmosphere, and very axis of rotation. Almost immediately, the gravitational pull that the moon exerts on Earth would vanish. Tides that once rose and fell twice daily would collapse into a new pattern dictated solely by the sun, as far weaker tug. Instead of dramatic bulges in the oceans, tides would shrink to perhaps a third of their former height, transforming coastlines that have long hosted life adapted to rhythmic inundations. Estuaries, tidal flats, and mangroves, ecosystems reliant on the moon's regular rhythms, would struggle to adjust, leading to cascading effects on fish, birds, and the human communities that depend on them. With diminished tides, the mixing of surface and deep ocean waters would slow dramatically. Nutrient upwelling, driven by the ebb and flow of massive water masses, plays a crucial role in distributing oxygen and feeding planktonic blooms at the base of the marine food web. Without the moon's motivation, ocean currents would become more stagnant, altering temperature gradients and potentially leading to dead zones where marine life once thrived. These changes might unfold gradually, but the long-term health of fisheries and continental weather patterns could be irrevocably altered. Beyond the seas, the moon serves as a stabilizer for Earth's axial tilt. Today, our planet wobbles within a narrow range of about 2 degrees thanks to the moon's steadying influence. If the moon were gone, gravitational perturbations from the sun and the other planets would drive our tilt into wild oscillations, varying by tens of degrees over hundreds of thousands of years. Such extreme shifts would transform the seasons. Summer could blaze on one hemisphere while the other endured a frigid, sun-starved winter. The comfort of predictable seasons would give way to geological epochs of climate upheaval. The moon's gravity also subtly slows Earth's rotation, lengthening our day by a few milliseconds every century. Remove that drag, and the slowing would stop. In fact, without the tidal braking effect, Earth's spin would remain slightly faster than today. Days might shorten by a fraction of a second over millennia, imperceptible to us in daily life, but measurable to future astronomers. At the same time, the absence of lunar torques would allow small wobbles and nutations in Earth's spin axis to grow, leading to variations in where the sun appears at noon and the angle of our skies. Nighttime itself would feel alien. With no moon to illuminate the darkness, nights would become stark, star-studded vaults of black except for occasional planets and meteor streaks. Many nocturnal animals that rely on moonlight for hunting or navigation, bats, turtles, certain insects, would face immediate disorientation. Human cultures built around the moon's phases, rituals, and calendars would lose a cornerstone of folklore and timekeeping. Our poetry, music, and mythologies have long been mingled with lunar light. Without it, the emotional resonance of the night would shift to something more void-like. Over geological timescales, the missing moon could even affect Earth's orbit. Subtle gravitational exchanges that once nudged our planet from the lunar torques would now come from other bodies, potentially causing minute changes in orbital eccentricity. These shifts might tweak the distribution of sunlight over continents, amplifying or dampening ice ages. In the grand tapestry of cosmic mechanics, the moon's sudden absence would be a tear that slowly unravels layers of stability woven into our world. In the end, losing the moon overnight offers more than just a darker sky. It dismantles stabilizing forces that shape tides, climates, and the very predictability of seasons. It reminds us how delicately balanced our existence is, perched between celestial neighbors. Though our planet would endure, its gravity and atmosphere unchanged, the loss of our lunar companion would set Earth on a new, less familiar path. It is a sobering testament to the moon as silent power and the hidden threads that bind us to the rhythms of the cosmos.